Hey everybody, we're going to finish off Unit 3, PowerPoint 2. It makes me upset that absolutely one of the more difficult lectures was the last previous one that you viewed. But moving forward, I think you will be pleased because things are a little bit simpler. I will at some point come up with a way to do a conference call with all of you through collaboration on Canvas, among other things, to answer any questions that you might have. But the good news with these videos are you're able to view them as many times as you'd like. So a quick, mini review. When we start this guy, humoral immunity is again the B cell side. So this is the one to combat bacterial infections. This is the one that gets activated that has one of three things occurring. One is it makes a huge proliferation or army of B cells to combat the infection. It also makes plasma cells, which have one job to secrete antibodies. And don't forget, it also has memory cells to make everything a little bit faster if you were to have a second exposure. So there's something that I need to talk to you about, which are antibodies, since they are unique to B cells. So B cells make them. And please remember, I mentioned that there are these macrophages. Let me do that a little bit prettier there. So we have all of the macrophages, which are the antigen presenting cells, and that all of them have these flags that they put on the surface, which is almost warning the rest of the body that it's being infected by some type of pathogen. Well, something unique to B cells is these flags that are actually on their surface are antibodies. So when they break down, when B cells break down the antigen that has gone through the antigen presenting cell and causes the issues, they create antibodies through their plasma cells. And then all of the receptors on the surface of B cells are antibodies. So that's written out for you right here. Please also realize that every single cell in the body, so I will write this for you, every cell in the body has the ability to be a macrophage. So when I ask you on the exam, which I will ask you, which cells have the ability to be macrophages, the answer is every single one in the body. Which ones are really effective? Well, B cells are great. Why? Because they're receptors that after they work as macrophages are antibodies, which are incredibly effective against a bacterial infection. So let's talk about antibodies, some specific information. This guy right here is an antibody. Notice it looks like the letter Y. There are two different portions. There is this area down here. It's written right here, but I crossed it off. This is known as FC. The C stands for constant. This is the area that's embedded into the B cell that you saw on the previous slide and acting as the receptor. So this picture of this Y are one of the flags on the surface of a B cell. This area right here is the opposite of the bottom. This one is known as variable as opposed to the bottom being constant. This part right here, where I'm drawing this little circle for you, is called FAB. That stands for antigen binding sites. That E. coli, or whatever that might be, here's your little guy. This is E. coli. It's going to come in and then attach itself at this antigen binding site right here, which is again attached to the B cell, and it's combating infections. So then the question is, what do these antibodies react to? Well, remember, peptidoglycan, LPS, all of the other aspects of bacteria that don't exist in our human eukaryotic cells will turn on an immune response. So I'm going to review this scribbling over here on the right side. This guy right here is FC. This is the constant region. What is it attached to? Hopefully you guys are thinking B cells, or a more basic name are macrophages. Both are in fact correct. And up here, this area is incredibly variable. So we say, how is it variable? Well, good thing you ask. It's on the next slide. This spot or opening is the FAB, which is the antigen binding site, where your antigen that's impacting the body and turning on the immune response is actually going to attach to. So then you wonder, how similar or different are antibodies? Well, if you take a look at this, the antigen binding region which is right here, the top part of that Y, 100 million to 1 trillion antibodies are made with different antigen binding regions. That means they are incredibly variable. But this part down here, this stem, is known as FC. The C stands for constant. The stem is not at all variable. It is just this area up here where the antigen is actually binding. I need for you to know the different classes of antibodies. They are fairly simple. We have IgG, we have IgM, we have IgA, IgD, and IgE. Do I need you to memorize how big they are? No, that's not really relevant to what I need you to know. Do you have to understand how to draw them? Absolutely not. What I want you to know is what their properties and functions actually are. So, IgG is the protective antibody that is constantly in our blood. IgG is found in the blood at all times, floating around just like neutrophils are to help us. When an immune response turns on, then the plasma cells from the B lymphocyte are going to secrete more and more of one of these 5 antibodies as needed. But I need you to recognize that IgG is considered the protective one because it fully stays in the blood. Then there's IgM. This is the first antibody that is produced after an immune response. So first antibody produced when immune response is turned on. That says turned, but you're never going to remember that. So let's fix that some way, somehow. Okay, there we go. Is turned on. The next one is IgA. This one is found in secretions. So the example I'm going to give you is breast milk. Then IgD. This one's real simple. We have absolutely no idea what its function is, but we do know that they serve as markers on the B cells. So what that means is we have a B cell, and IgD is sitting on the surface like the little flags in all the previous slides, but we don't know its actual functionality. And last but not least is IgE. This one is secreted during an allergic response. So secreted during allergic response. These are the 5 classes. Expect to see some type of matching where I give you the function and you tell me which antibody does it. This IgG right here, just in case some of you are doing additional reading, Ig in general, or another name for an antibody, is an immunoglobulin or immunoglobulin. So when you see that, you know where it's coming from. In an antibody response, you can read what's written down here in number 1 and number 2, but instead I just want to mention when we have an immune response or an inflammatory response, because some invader is in our body, it's going to activate either the B or the T cells. With the T cells, there is no antibody, so we're not really going to talk about that, but with B cells, there is in fact an antibody that is secreted from the plasma cells. Please take a look at the chart on top, specifically this one first. So the x-axis is number of days, and the y-axis is how much antibody was found in a serum of a patient when they titered it and checked it. So there's an exposure. Notice the first one that's going to show up. Let me go back for a second. Remember, IgM is the first one produced. So first one that shows up is your IgM. And then the first one, go back one more time, IgG is the protective one that always stays in the blood. So shortly after, within about 10 days in this particular case for tetanus exposure, IgG is now in the blood and rushing to the area. This is a first response. Notice this is about 2 weeks before something is actually happening. But this is where memory cells and things that we discussed before come into play. The second chart is a secondary response. Patient has exposure, so this is day 0. And notice by 1 week's time, not only is IgM there, but IgG is produced a lot faster. Compare one curve to the other. And why is that? Because secondary response is working off of memory cells, which recognize, hey, tetanus came back, because notice both of these are tetanus. So we are again talking about, here we go, let me straighten that out a little bit. We're again talking about situations where there's a specific immune response, or also known as adaptive. I'm going to make this complement stuff super, super simple for you. So remember, first time around when we talked about complement while we were still seeing one another, which, man, I wish we were still, it basically was a Mac attack. So it's floating around, it's 20 or so proteins using the circulatory system. These proteins are secreted from the liver. Look at your Unit 3 PowerPoint to the first part that we still did in class. And I mentioned to you there's specific and adaptive, different kinds of complement. Before, the simple one with complement, all I said to you was it causes a Mac attack by poking the bad guys. Well, now we're going to look at complement in a specific immune response. I'm going to add one thing to it, and this will probably be the simplest thing we learn in this unit. So here we go. We have complement. It's a protein. When it pokes the membrane, it causes a membrane attack complex. CM is short for cell membrane, which then causes a Mac attack. What happens with a Mac attack? There's lysis of the bad guy and it pops. The only thing I need you to add as the difference between non-specific complement and specific is with specific, antibodies are involved. So specific involves antibodies. What does that mean? It works faster and it's more specific to any individual that has come in contact with something pathogenic. So same thing, specific or not, it causes lysis by poking the membrane, causes a Mac attack. But if it's specific, it involves antibodies, which makes it work faster. See, told you that was simple. Okay, so don't forget about natural killer cells. We had mentioned these before. They're floating around on the body, and then they attach to the pathogen. And then the natural killer cell's Golgi aligns so that it is completely lined up with the bad guy. Then they secrete perforin, which pokes the membrane and causes our beautiful Mac attack. It does this when the body has cells, we won't talk about MHC, that are non-self. In other words, don't belong in your body, and your immune system picked up on that. This is a bit of a review from the last PowerPoint because I acknowledge that the immune system is not the simplest thing on the planet to understand. So here we go. Antigen, let's say it's E. coli. There you have the antigen presenting cell, which will take it in and then put flags on its surface to let the rest of the body know something is wrong and going on. Next, T helper cell helps determine, is it bacterial or viral? Here between the two, we have the receptor CD4. If this is a bacterial infection, T helper cell goes this way. There's a proliferation of B cells to make a lot of them. And then also memory cells are made, which help with a second exposure. And plasma cells are made, which have one job, and that's to secrete antibodies. So if we back up right now, and we have an antigen coming in and it's viral, then the T helper cell will decide, oh, we got to turn on the cytotoxic T cells, which are TC. Another name for it is TE, and the E stands for effector. I'm telling you this in case you're reading additional materials. What happens, same thing as on the other side, they proliferate and make a whole lot of T cytotoxic cells and also memory cells. The cytotoxic cells cause a Mac attack. It also uses perforin, just like natural killer cells. And then when the entire process is done, TS or T suppressor comes into play so that it doesn't go out of control, because we do not want healthy cells being killed off by our immune system. Last but not least, in the middle, let's say you have a second exposure to the same thing. Right away, depending on if it's bacterial or viral, the memory cells are turned on and the process is much faster because the immune system has memory and remembers what happened last time, can combat the pathogen a lot quicker. So a couple immunological disorders. This is not difficult because there's only a couple that I actually need you to focus on, and I will point out which one. This is also going to be a kind of matching / fill in the blank area of here's what's happening, what type of hypersensitivity it is, and what does autoimmunity mean. So as we had mentioned, another word for hypersensitivity is an allergy. We'll look at the different types, and then I will tell you a tiny bit about autoimmunity. So type 1, this is our number one focus for our exam. So when there's an allergy, what's happening is the immune system is reacting to an antigen that it would normally ignore. So let's say all of a sudden you're breathing, everything's fine, and then spring comes. So now the antigen might be pollen because you have an allergy during pollen season. So then that allergen, which again I'm using the example as pollen, will cause an immune response or reaction if the person is sensitized to it. If you're sensitized to pollen, that means that you react to it. That means that your body turns on an immune response. If you're not sensitized to it, or it's not an allergen for you, or you're not allergic to it, your body simply will not respond. So remember, the immunoglobulin or antibody that's produced during an allergic reaction is IgE. Make sure you remember that. So during a type 1 immune response, anaphylaxis can occur. A lot of you have heard of this, but you don't actually know physically what's happening. So if you have allergies, you always have localized anaphylaxis when you come in touch with your allergen. What does that mean? The antibody IgE gets released in larger levels, which causes your immune system response to turn on. The scary one is a systemic anaphylaxis. Systemic means that it impacts the entire body and all organ systems. An example or something that most of us know is a high allergen and causes issues is, let's say, a peanut allergy or shellfish. Those are the two things I can think of right off the top of my head that often can cause a systemic anaphylaxis. So what happens? Well, it starts as localized, but then it begins to spread. So you may have heard people say if they eat something such as peanuts, they notice their throat is closing and their mouth gets itchy and they're unable to breathe. So histamine, which is our cytokine, by the basophils and mast cells gets released in absolutely insanely high levels. So blood pressure goes down, smooth muscles contract, so think about lungs and everything. This causes your airway to become constricted because everything is swelling from the immune response because so much IgE was released into the body. And then your lungs tend to fill with mucus and you go into what's known as an anaphylactic shock because the blood pressure drops or bottoms out so much, which is why peanut and shellfish allergies causing systemic anaphylaxis is so dangerous, because it is in fact easy to kill a patient that has an allergen to one of those two food items. So there are allergy shots. This picture here is somebody's back where they have allergy testing and they are getting poked. Notice here is a reaction as opposed to whatever these two things are related to isn't. I'm not a huge proponent of allergy testing because it's expensive and time consuming, and often answers are really not gotten unless if it's a severe peanut type of allergy. So type 2, we don't have a big focus on it, but I need you to know an example. So type 2 is Rh factor in the blood. To make that, I guess, English, I will say that I have B type blood, but I know that I'm B positive. So when people talk about positive versus negative in blood types, that is the Rh factor. So in this picture, this is dad and this is mom. Notice dad is a positive Rh, so let's say he's B positive. Mom is a negative Rh. The baby happens to be positive. The issue is if mom and baby don't match, the mother's immune system turns on and thinks, oh, something's wrong, and it will attempt to kill off the baby in the sense that it's a foreign invader. When a woman has a baby for the first time, Rh factor is irrelevant because this works off of memory cells. So this would, the baby the first time around would be like a first exposure. But once a woman has already been pregnant, for second babies, they always do Rh testing, because if the Rh of the baby and the Rh of the mother don't match, these little pink things right here, these are antibodies, and it's protecting her body, and then it's going to try to eliminate the pathogen. Unfortunately, the pathogen is the baby, which is why Rh factors come into play. That's an example of type 2 immunity. Type 3, I just want you to know one thing, it's a localized reaction, not systemic, and that's it. So type 1 and type 4 are the two I want you to know about. Type 4 is known as a delayed hypersensitivity. Poison ivy is my example for you. And my second example is someone who has a latex allergy. So what's happening here, it means the person comes in contact with an allergen and their hypersensitivity or sensitization response comes approximately 12 hours after exposure and not right away. So here is the latex allergy. This skin outbreak, right away the patient or person with a type 4 hypersensitivity will notice the itchy and the scratchiness, but they won't actually have skin that looks like this for about 12 hours at a minimum. Another example for type 4 is TB testing. Those of you that work in healthcare, or any of us with children, or if we're up to date on our vaccinations, you go in and they do the tuberculin test, which is they poke you with this, they used to be white, I'm not sure, with this little thing, and then they give you this card to take home and say, hey, call us in a few days if the bump is this high, or the reaction is this big, because if you're reacting, that's an antigen and, oh my God, a duck in my recording, I'm so sorry. That is if you have an antigen antibody reaction. If the bump does not get big like this and say remains flat, like the skin right here, then you are not having an allergic reaction, which means you're not positive to the test. Because if you had been exposed in the past, that would be the only way that you would have a reaction like this. So type 4, the examples are latex and TB testing. So last two concepts, autoimmune diseases. In simple terms, this is your body becoming sensitive to your own cells and then making antibodies against your own tissues that kill them off. So examples of this are lupus, multiple sclerosis, and rheumatoid arthritis. Your body is fighting off something that is a normal, healthy cell, causing breakdown and degradation. With multiple sclerosis, for example, it starts breaking down muscle tissue, skeletal tissue. It impacts a person's ability to be mobile and everything else along with it. And this is a genetic illness. It is autoimmune. Autoimmune means that your body is fighting off itself when in fact it's healthy. So here are 4 primary ways to get gain or get immunity. This is also going to be a matching section. And these guys right here, this is the terms I need you to know. Natural acquired active, natural acquired passive, artificial acquired passive, and artificial acquired active. I need you to know what that means, and then potentially an example. There's really 3 that I focus on, but I'm going to share all 4. Naturally acquired active is when you become exposed to something and develop some type of symptoms. An example here could be chickenpox. So it's naturally acquired, you caught it from someone else, and active immunity, your body is going to provide resistance to it. So the second one, natural acquired passive. The difference between active and passive is it isn't actively happening. So when a woman is pregnant, an example there to provide short-term immunity is when antibodies are passing to the fetus from the mother during the pregnancy. So babies are born with a certain amount of natural acquired passive immunity. Then C, I don't focus too much on, but I want to mention it. This has to do with short-term immunity, and it's artificial acquired passive. So A, B, and D are the ones I'd like you to know. Artificial acquired active, this one's real simple. It's a vaccine. This is when you use or cause antibody formation in the body by having a vaccine administered or giving or getting a vaccine. This is artificial because you didn't just become exposed to it. You literally went to the doctor's office to get it. Here are pictures to kind of help you with those four. And then this now is going to conclude Unit 3. I am posting a new schedule with new deadlines, new assignments, new exam dates, and everything else. So please look at these past two, because these last two videos, so Unit 3 PowerPoint 2A and this one we just completed in B, are the ones that will finish off all the information for Unit 3.